we are up. Welcome to the live lesson planning stream here. And tonight's goal is really to plan what we're going to do tomorrow when we start working on exponential functions and exponential equations. Now, these are really fun, but they have a lot of new rules. So one of the things that we'll teach first are the rules. Once you learn the rules of exponential functions, you'll see that they're not that much different than anything else that we've done all year. They're just kind of fun because you'll get to play with something new called the natural logarithm, which, it's new and it's interesting. So what we're going to do, honestly, the book sucks when it comes to exponentials. So we're going to use Paul's tutoring stuff here. So we'll jump over to that. And one of the other things I want to look up are rules for natural logarithms. Okay, so there's 11 rules that you need to know. Let's see if this is a good site that has all of them. All right. Yes. So they're just like we have for exponents, where we have the product rule, the quotient rule, the power rule, the negative exponent rule, the zero exponent rule, all that stuff. There's rules for natural logarithms, and I can't wait to teach you guys these. So that's where I'm going to start. Let's just see if there's anyone watching, because I'm not going to put this on Remind. Maybe I should. I don't know. I'll just send it to students. I don't want to blow parents up tonight with the Remind. All right, so that just went out on Remind. And good evening to all. Here we go. So the 4 key natural log rules. All right. We'll start with that. The product rule. Okay. So I'm going to create a new notes page here, and we are going to call this log rules. All right, so where am I getting this from? Prep Scholar. We'll drop that in there. So this is so we got the product rule. And that is the ln of x times y equals the ln of x plus the ln of y. right, this is good. We should just grab this instead of writing it. Cool. Okay. So tomorrow will be a great day. It could be a good day. Like, it'll be a good day from the perspective of class structure because we're going to be writing notes and working a couple of examples and just getting our feet wet. And then Friday, let's see, tomorrow's Thursday. Then Friday we will like practice using the skill. And I'm going to have to unfortunately truncate quite a bit of this chapter and just teach you what you need to know, because then Monday, Tuesday, and Wednesday of next week, I just want to be doing star. And I also want to focus on star for the Play Startion, which we have 17 kids registered for right now. So that's exciting. That's the most that I've ever been registered for one. But that means I have to call 17 parents. So I got to get on that. Okay, next up is the quotient rule. And here in the in this chat, I want to say thank you so much to Nick for making all of these mods to the Discord server, so it looks so cool and is very functional now. I think when we get into the thick of it, doing work and doing lots of homework live streams, that will really become useful. So thank you to Nick for that. Not in a million years could I have figured out how to do any of that. Okay, next up is the reciprocal rule. Okay, and this should be the fourth key rule, the power rule. If you can believe it, when I took Algebra 1, they did not teach this. So this was an Algebra 2 topic, but now they teach it in Algebra 1. So we would have ended Algebra 1 with basic quadratic equations, and we wouldn't have seen that again until Algebra 2 in your junior year. So they've really pushed a lot more into Algebra 1. So here are some more properties of logarithms. This is going to be a big one. The ln of a negative number is undefined. The ln of 0 is also undefined. The ln of 1 is 0. The ln of infinity is infinity. The ln of e, which is a transcendental number that we'll talk about, is 1. Ln of e raised to the power of x is x. E raised to the ln power of x equals x. So this is kind of confusing, but this is one of those things where you'll always be allowed to use your notes. So good notes will always be able to just refer back to these. Wonder if they're going to give us some examples. Sample problems. I love it. Oh, and look, they have everything worked out. That's great. Oh, these are great. Oh, you know what? I know where they got this image from. Check this out. I can show you where this dude got this image from. This guy got this image from Pixabay royalty-free images. If I go in here and I type chalkboard, watch this. Whoa, I was supposed to say chalkboard. Look, let's see. No, I seen it on here. There it is. Look. Ha ha. I found it. So look, that guy got this photo from this royalty free image site. Like, it doesn't even have logs on it. So why is it he just got a picture of something that looked like math on a chalkboard? Awesome. Okay, I don't know why that was so exciting, but okay. I want to make sure. I want to check and see how fast the stream is going now. Let me hop on my own stream. See if it's anywhere close to like in sync with what I'm saying.
Looks pretty synced on my side, Mr. Maroon.
Oh, really? Okay.
Yeah, looks pretty synced on my side.
So ultra low latency with a VPN is the way to go then.
Yep.
Can we write the notes if we have our journal? Yes, Emma. Yes, you can. Yes, absolutely. Okay. Wow, 3 people. I mean, it kind of feels like empty compared to the 24 people we had last night, but I mean, yes, it's church night, and also this is not a homework thing. This is just lesson planning, so it's okay. There's only a few people. Or quite frankly, no people, because I used to just do this part alone. All right. So problem 2. For the student who asked me about writing notes right now, absolutely you can write notes, but I'm probably going to change. This is just a skeleton that I'm making right now. So these notes can change dramatically. I mean, the key aspects of the notes won't change, but kind of I might find better sample problems or something. I just like that these sample problems actually have everything explained, which most of them don't. Right? Wow, it is very fast. Let me try just writing something. 1, 2, 3. 3 seconds. Okay. That is so much faster than what it was before. I mean, that's near real time. Here, let's do something just for fun. Anybody on live chat, tell me what this equals. Wow, that's fast. So that's real time. Wow, I didn't think it was possible. I thought my connection would be too low.
You know,
Is it? Yeah, go ahead.
That was fast. That was fast, Mr. Merlin.
That is very fast. Honestly, it was so fast that I barely got it written down and I saw it pop up. So that I can't believe I just didn't think to do this before with the VPN. I think it's the VPN because what's happening when you have a connection, okay? It's using what's called TCP/IP, which stands for Transmission Control Protocol, Internet Protocol. So, or something about packets. So basically, the way it works is it sends a packet one at a time. And it says, then the packet has a ping back request that says, did you receive me? Well, this is going to happen millions of times every second. And that really bogs down bandwidth, especially when you're doing video. So the best way to do it is to do UDP. So I changed from TCP/IP to UDP. And UDP functions more like a coaxial cable. It's just a flood of data. And so packet loss doesn't matter, where in TCP/IP, packet loss will shut down the stream. And so then I got the server based in Dallas, so it's very close. That means that wherever you are getting on the computer, it only has to hop to the Dallas server and then hop here, where before it was hopping all over the country. So there was like, if you run what's called a trace route, you could see like 24 hops between when I write on this computer and when you see it. And again, those are each of those are going to chew up milliseconds. So that's why by the end of it all, if you're just using Google to host your live stream and you're not filtering it through a content delivery network like NordVPN is offering with their low ping, low latency, ultra low latency servers, is that you're going to see long lags, which is what we saw at 6 to 10 seconds at a minimum. It was painful last night compared to this. So I'm excited. And I hope I didn't just bore everybody with all that tech jargon.
Oh no! I was sitting here listening to you in the Discord and watching the stream. When you said 1 + 1, everything was synced.
That's so great, man.
I paused the stream just to make sure. Well, I didn't pause the stream. I paused your voice. I just muted the stream.
That's great. So Emma, we're actually going to work these problems here in a second if you want to, so you can get your feet wet on some actual problems. And so we're not just writing notes. Okay, that one looks like a hard one. So let's go back up here and we'll work this example together. So let's just start with the product rule. The product rule states that the ln of x times y equals the ln of x plus the ln of y. Let's read it out. The natural log of the multiplication of x and y is the sum of the natural logarithm of x and the natural logarithm of y. I love it. So the example they give is ln of 8 times 6 equals the ln of 8 plus the ln of 6. So that would be, and I write ln because this could be confused with a 1. Like this, I know somebody's going to think that, you know, that what I wrote was 1 in. That's confusing. So what I like to write is I write big, like a big capital L and then a little tiny capital N. And that's actually how it looks on your calculator. So let me pull up the calculator so you can see you're going to be using this key quite a bit. So let's take a look at the calculator. This key, if you see LN, it's to the left of the 4. It's all caps. So that's why I think it's a good idea just to use LN with the all caps. Why is this so weird? Okay, there. Let me shut that down. All right. So ln of 8 times 6. Well, I don't want to do that. That's wrong. That's not even true. So the ln of 8 times 6 equals ln, well, I almost broke my own rule, ln of 8 plus ln of 6. Now, here's the thing, guys. These are numbers, okay? This is a number, and so is this. So what we're going to do is jump into our calculator and just put ln of 8 and see what we get. And we'll prove that what I was going to write before was actually wrong. So let's see if the ln of 8 plus the ln of 6 is equal to the ln of 8 times 6, which would be the ln of 48. We'll see if that's true or false. Here we go. And I'll clear the memory here. Second plus 7, 1, 2. Okay, so we'll go home. And we're going to type ln 8 and hit enter at 2.07, whatever. And then ln of 6, you just hit ln 6, enter. All right, so we're going to add these together, right? We're going to add that to this. And this is the ln of 8 plus the ln of 6. It's all happening here. And so it's called 3.8, okay? So remember what I was about to do. I was about to write this. I was about to write ln of 8 times 6. Let's see what if that's equal to 3.87. Let's see if it's the same. Oh, it is the same. Very, very interesting. That is super cool. So this kind of actually is somewhat confusing. The way they've written it, I don't like that, right? The way that I would have written that is I would have written ln of 8 times 6. Like that. Wow, that is so cool. That's real time. It's happening, and it's like a less than 1 second delay. I love it. Because the way they wrote it here, they make it seem like you can't do that, because they make it seem like, oh, this is something different. That's all the same thing. That's what's going to confuse students right there. Let me erase all this. You know what we're doing here is called anticipating the set. Okay, that's what they call it, anticipatory set. That's what I'm doing right now. Oh no, don't freeze on me. Don't you freeze. I'm going to show you how hot this computer is. Check this out. This computer's got to be burning up. Check these internal temperatures. It's 136 degrees, 134 degrees on the core. All these cores are nearly 140 degrees.
Well, I can tell you this. You got a really nice CPU over there. I'll tell you that.
Quad core? Or no, it's hexacore, 8 cores, i7. Yeah, it's the i7.
I was gonna say it's probably built. Do you have a desktop, or is it built into the motherboard?
Oh no, this is the Surface Pro, so it's all in one. It's all on board.
Okay. Yeah. There you go.
Let me show you something. If you're into this, you want to see the specs.
Yeah.
Let me hit Windows key R, and then run dx diag.
Yeah. If you sometimes I can tell you this. Sometimes your computer's running slow. If you do %, and hit enter, it brings you to this file explorer, and you delete all the files in there, and your computer runs faster sometimes. Mine does that when I'm gaming, especially because I don't actually need.
Mm-hmm. Well, when I see this happening, look at processor utilization. Look at processor utilization. 100%. That's too much. Right? I mean, that's what's slowing it down. So anyway, here's the setup. It's running Win 10 Home 64. It's running the correct build. It's got 16 gigs of RAM. This is a 10th generation i7, 8 CPUs. I mean, the fact that it's slowing down and getting hot with that much firepower is what I was talking to Microsoft about, saying this should not be happening. Anyway, let's get back to work here, because I think we have at least one student or two students who's actually going to try to learn something tonight. So here we go. Now we learned something about the product rule. Let's do another one. Let's do ln, and then do let's see, 4 times 6. So this would be the same thing as, now we've proven it, the same thing as writing the ln of 24. Right? That's a lot easier than saying, oh, okay, this is equal to the ln of 4 plus the ln of 6. Right? These are all equivalent statements. This is the ln of 4 plus the ln of 6. But I'm assuming that that could be useful at some other time. So that's the product rule. It's pretty cool. Oh, wait, now the latency is going a little bit. So we're at about 2-3 seconds now. Maybe I spoke too soon. Okay, so now the quotient rule. Ladies and gentlemen, here's the quotient rule. The ln of x divided by y equals the ln of x minus the ln of y. So example, again, I don't like the way they're writing it. So ln of, open parentheses, 7/4 equals the ln of 7 minus the ln of 4. Okay, so I got an example that we can try in the calculator. How about the ln of 12/3? Right? We know that 12 divided by 3 is 4. So what we're going to see is, let's see, ln, and then we'll do ln of 12 minus the ln of 3, and we'll see if that is that equal to the ln of 4, right? Let's go check. So I want to show you all the things that you can do in the calculator. These are really easy. So let's do alpha. Wait, no. Let's do ln and then hit alpha y equals enter. And then what did I do? 12/3. Okay. Oops. Wrong. Okay. Let's hit that. Okay. 1.38. Now let's try ln of 12 minus ln of 3. Same thing. Well, now let's try ln of, what 12 divided by 3 is 4. So let's try ln of 4. Should be 1.38, right? Boom. Those are all the same. Okay. Yeah. I like it. A lot of different ways. Now, where this is going to become more interesting is these are kind of silly examples, but good for us to practice with. But here's what I want to see. Okay. When we start replacing ln with not just like, so that, what about the ln of x squared over x? So is this equal to ln of x squared minus ln of x? This is where students will start to freak out. So what we would have is some kind of equation like f or x. Yeah, it's 3 seconds now. But we'll get there. We'll keep it with numbers first, and then we'll get to where we start putting letters in. That'll be good. And we'll just make those examples up on the fly as we go. Now, what is this reciprocal rule nonsense? ln of 1 over x equals negative ln of x. What? ln of 1 divided by x is equal to the negative natural logarithm of x? Yeah, I want to see that in action. Okay, so they're saying ln of 1 over 3 is equal to negative ln of 3. Now, wait a minute. The natural log of the reciprocal of x is the opposite of the ln of x. But wait a minute. We just read the quotient rule. So wait a minute. So ln of 1/3 is also equal to ln of 1 minus ln of 3. We just learned that. So let's see if this, and this are all the same thing. That would be really, really cool if it was. Just, I don't really know. So let's try ln of 1/3. Okay, we'll call that negative 1.09. And now let's try negative, and then we'll do ln of 3. Same thing. But now let's do what I said, ln of 1 minus the ln of 3. If this is the same, my mind is going to explode. Oh, yeah. So the rules work. Oh, yeah. So I yelled out, oh, yeah. And then it was like 3 seconds before it was on the stream. So cool. That's exciting. I love that. I did not know that. Let me just get rid of all that. So definitely we want to be playing with the calculators tomorrow. One thing I want to check is, can Desmos do anything with ln? Let's see. Let's go find you, Mr. Desmos. Here we go. Wait, I think I set it up as an app. Did I? Thought I did. Yes, I did. Test mode. Here we go. Hey, Nick. You know, if you're into this, you probably might already do this, but go to Chrome and do Chrome : / and then type flags, and you'll be taken to all the experimental features, which you might want to play with. And then that's why I download down here. Oh, it's Chrome. It's right here. Here, hang on. I want to download something. Oh, I did?
Yeah, it's just my Wi-Fi company's being stupid, right?
No, I bet it's mine. I'm gonna download something first before I show you this. I have to download this thing first. Live Zoom, we're gonna do Alt-Z. All right. So now let me show you. If I go now, check this out. Check out this zoom thing. If I hit Alt-Z, it's going to zoom in on that part of the screen, and it'll move with my mouse. That could be useful. It's like back in the TI problem. Like if I said, hey guys, let's take a look at this fraction right here. Boom, brings it up. Fun. And I can change the zoom level. Like I can change it to 3 times, which it might be too much. Now Alt-Z, really close. Okay. And so I could say, guys, focus down here right here at this LN key. Click that button. And then, right, so click LN, then click this button right here. This is the 4 button. Like, let's do something fun. How about the LN of pi? What could that be? Okay, if you didn't know how to click pi, you would first click the 2nd key, boom, and then go down here and click on this little dude right here because that's the pi key, boom. And now you've typed ln of pi. Make sure you close those parentheses right there. And now go down here and click on enter. Ba-bow. All right, it's actually a number, 1.144. Wonder if that's some kind of weird, special, mystical number. Okay, how about the ln of pi squared? So, like, bingo. ln, second, hit that pi, and then go over here and hit this x squared button to square pi. Ba-bow. All right, let's hit it. So we're going to do the ln of pi squared, ladies and gentlemen, by hitting enter. And we see that the answer is 2.289. Now, that's interesting because it actually looks like that is just 1.144 times 2. Okay, that blew my mind. That right there. So the ln of pi squared is the same thing as taking the ln of pi and multiplying it by 2. So are you telling me, wait a minute, are you telling me that if I hit ln and then I put 2 pi, that it's going to be the same thing as ln of pi squared? No, that's not possible. No, it's not possible. Now, wait a minute. So wait, we take the ln of pi and we multiply it by 2. So how about this? ln of pi, and then do like this, times 2 on the outside. I bet this will be 2.289. And it is. Oh, yeah. Well, that was cool. I didn't even anticipate going down that little journey. What am I doing now? Oh, I was going to show Nick these flags. So you go to this web address right here, chrome://flags. And this okay, you can enable all these cool experimental features. One of the new experimental features that I'm really interested in, like learning how to use, is called tab grouping. So if you hit Control F and you go over here and then type tab group, like GR, okay, you'll see tab groups. Okay, so allow users to organize tabs visually. All right, so enable that. And then if you right click on one of your tabs, you can now add to new group. All right, and it gives it a color. So we're going to see, we can add this to existing group, and this, now they're both purple. And so you've now you see there's this line, it's grouped the tabs together. So it kind of looks different. I'm not really sure what the purpose would be, but that's how you do it. So let's go back and do some more work. Now you guys see why it takes me 5 hours to plan a lesson, because I just go off and do something else for a while. Nick, if you haven't already subscribed to this guy, you should go on YouTube and subscribe to Theo Joe. And then look for his video on Chrome. His most recent is one of his recent videos on Chrome update. He'll tell you all about it. This is the channel name, Theo Joe. And I want to get, when I get leveled up on Discord, he has discord.gg/TheoJoe is his Discord. I want to have discord.gg/OGmath. And I want that to be my Discord, because that would be really easy to remember. Theo Joe, a cool dude. Okay. The power rule. ln of x to the y. Oh, look. Well, okay, so actually this is what we just did with this pi thing is explained with the power rule. So check this out. So the ln of pi squared, according to this rule right here, is equal to 2 times the ln of pi. And that's basically what we found by accident. That was cool, though. Okay, I wanted to go look on Desmos and see if Desmos had the ability to do any of this. Oh, wait, I wanted to use the app in test mode. Okay, can I type in ln of 5? Okay, it calculated it, but did it graph it? No. What if I type y equals? Oh, now it graphed it. That's cool. Oh, I see. Because ln of 5 is just a number, it's going to graph. How about if I put 5x? Whoa. Yeah.
I got a problem with my computer. You told me I need to update it, so I'll be back in about 10 more minutes.
Sounds good, sir.
All right, so see you then.
All right, bud. Yes, sir. Okay. So I wonder if this is equal. So y equals ln of 5 times ln of x. That's interesting because, oh wait, it's supposed to be plus. Oh yeah, that's neat. That's really neat. So we just demonstrated the product rule right there. I put a plus sign in there. That's neat. This is a weird function. The natural logarithm is the opposite function of the exponential. So we'll do ln of x, and you see it looks like this. All right, let me expand this out. Now look at this. So let's try y equals x. No. Y equals e raised to the power of x. Look, when I zoom out. You see how they're kind of like mirror images of one another? So that's really weird. What has really happened here is you've taken, like, look, let me replace it with numbers. I don't want to mess this up. So if I put in ln of 8x, and then I do this, no, that's not the same thing. I was going to try to demonstrate something cool here. What if I put the 8 on the outside? It's interesting. Like basically, these are inverse functions, kind of like if you have y equals x squared, it looks like that. But you can then do y equals the inverse of x squared would be square root. Y equals square root of x. And all that's happened is they've rotated the x squared function to the right by 90 degrees. So these are intimately linked, the x squared and square root function. If you just look at this, you take this part of this line and you lay it on its side, it's going to be this right here. See, look, this guy is crossing at, this green line is crossing here at 0, comma, come on, at 25, comma 5, if I could get it, there, 25, comma 5. Well, I bet that at -5, this sucker's at 25. See? Right there, so. There. See what I mean? Well, that was interesting. So we basically, yes, we can do log stuff on the calculator. I mean, on Desmos. So we can use Desmos to help us as well. Okay. Well, thank you. Let's credit her. Environmental biology and geography. Well, she's doing good at teaching math. Let's go ahead and credit her up here. Thank you very much, Miss Sarikas. All right. Are there any other rules we need to learn? Properties. We need to learn these properties. So if you're writing down all this and you're still on the live stream, I guess we have to memorize these properties. And I'm going to go off mic for just a minute, and then I'll be back to kind of flesh out the lesson plan. So let's see here. The natural logarithm of a negative number is undefined. The natural logarithm of 0 is also undefined. The natural log of 1 is 0. The log of infinity is infinity. The log of e is 1. The log of e raised to the x power is x. E raised to the ln power is x. Okay. We did these sample problems. Yeah. So I want to do Paul's notes real quick. Because Paul's notes have a bunch of cool problems. Okay, so we want to solve these problems. And we can show the solutions. Wait, these are the same ones. Okay. We definitely want to look at these rules here. So this is coming from Paul's notes.
Mr. Really?
Yep.
All right, Scott back. Some stupid update.
Hey, it happens to the best of us, man. Windows. Are you running Windows?
Yeah, something with the security, something like that. Like they said, the whole thing about the iPhone thing, you know, about the security thing for them,
Yeah.
happened to us over here. Well, especially for my model and whatever Windows I'm on or whatever.
So, Nick, are you, I mean, I hope the answer is yes. Are you planning a career in IT?
I kind of do. You know, I was looking at Mr. John. I've kind of...
I want to show you what John has. He is CIEE. No. CCIE. He's CCIE. So this is what you want to go for right here. Cisco Certified Internetwork Expert is a series of technical certifications for senior networking professionals who design, build, implement, maintain, and troubleshoot complex enterprise networking infrastructures. This is what John has. So if you want to be John, you got to be CCIE. I mean, he is so much more skilled than what we use him for. I mean, for heaven's sakes, he spent 45 minutes today setting up a printer in my class, and it's got to make him feel, you know, kind of like a math genius teaching kids how to do 1 + 1.
Yeah.
Now, the first step in getting the CCIE would be like the CompTIA Network Plus. So this Network Plus certification from CompTIA would be like a real good, this certification here is something you could get now just in your own free time. And it's not that hard to get. It's a good step in the right direction. This would get you a job on a help desk or in a, not necessarily a sysadmin role or a network admin role, but it would definitely get you in the room with those people, with the CCIE people. And then the other one that pairs with Network Plus is A+. So CompTIA A+. This is going to be more like teaching you how to do, it's really, you probably know all of it already. It's basic stuff about computers. You know, what is a motherboard? What is RAM? How does that work? You know, and so you have to learn all the technical words for like Cat5. What does CAT stand for in Cat5? This is simple. So I would start with the CompTIA. Here, I'll zoom in on it. A+ certification. Yeah, go ahead.
Could I actually do this now? I'm kind of
Yes.
the waiver thing and
Absolutely.
really quick.
Yeah, you do it now. And actually, it's something I was talking to Nettles and John about is we should offer, because if our school can offer a course in computers like this, where at the end of the course you obtain an industry certification like the A+ certification, for example, our school gets huge bonus points for getting people certified in things. That's why what Miss Adams is doing with the rotations. If those kids finish those rotations in their health class and then become a licensed vocational nurse and become LVNs, it's big for the school. So I would love to have a class where at the end of it you got the CompTIA certification. Now, register for CompTIA and see what that's all about. Like, you have to buy the exam, and so here's the voucher is $226, but that's something that as a school we would pay for if we had the class. Like, we pay for you to take the SAT, we pay for you to take the TSI. We would pay for you to take the test, maybe once or twice. And if you failed it twice, then it would be on you to take it. But would you take that elective if it was offered?
Oh yeah, big time. I really would.
Big time, right?
Big time, yeah.
So the CCIE path, that is a huge monster. But you can see how much does a CCIE make? Check this number out: $138,000 per year.
Really?
Yep. So you'd be a network admin, sysadmin. That's a cool role. You'd have root access to all the Linux servers. So that's what Network Plus gets into Linux and Unix and teaches you how to use the PowerShell in Windows to do all kinds of cool stuff, and hashing and stuff like that. You would love it.
Mr. Miller, I got a quick question about.
Yes, sir.
Or her, Miss Aber, sorry.
Yep.
Is she just the hands-on computer teacher? Like, she just teaches you what RAM is and what stuff like that? Because I seen it on the TV in the lunchroom, something like that, with the kids doing something on the computers, or they were taking apart.
Well, what they're doing in there. See, it's good. It's good. And Miss Aber is the person who is currently she's building the groundwork for something like this. But you saw what they were doing. They were taking apart old computers and making like jewelry out of them.
Oh.
And that's not exactly what we want to be.
Not at all.
But what she's doing, where I think that's all good stuff, because that's getting the kids hands on with computers and they start to see the boards and start to see the chips and stuff. So I love it. I think she's a genius for doing it that way, because it's a nice, easy way to get your feet wet. But we need to be doing more, and we could be doing more. And so I know that Miss Aber would love to do a class, because she's the BCIS teacher and she's like the tech person, and she knows a ton about computers, and you see how she puts together those videos. So she knows about video editing and stuff. So we need to offer robotics. Okay. And then we need to get you kids. We used to have robotics 2 years ago. We had a club, but what we want to do.
Wait, sorry about cutting you off. But Miss Work, she used to, her old school, I asked her about it. She used to teach robotics. So.
Oh, so I'll go talk to her.
Yeah, she said wherever she was at before she came back to West.
So here's what we want to do. We want to get you guys registered to do the best BEST robotics competition. Okay. See this? Look at this. You would build something like this. And then I did this in high school. It's so much fun. You build a robot and there's like a challenge. Okay. And then you build that robot to go perform the challenge. And here's an example of the competition. Okay. The robot's got to go do something. Like when I did it, it was a mission to Mars. This was this was like 1998, so it's so much more advanced now. But here's the problem. Okay. Let's go to best robotics and then package price. Look, so your prices for the whole thing as a school would total about $10,000 per year, I think. Wait, this is the wrong website, but the whole bundle. Okay. Well, this is just to control the robot. This doesn't even, all this stuff adds up to like $5,000 or $6,000 in parts. But if we go to best robotics, click on it. Boosting engineering technology. Okay. So the competition. This is what you would do. You have to go to a 2-week camp at, I think, Texas Tech or Texas A&M over the summer. and that costs like $2,000 per student. So anyway, I won't go through this whole thing, but yeah, you've got to have a project engineering notebook, and you've got to have a presentation that you do. It is a ton of fun. Now, see, get involved, register a team. And here's where I think we'd have to pay. You have to pay a ton of money. Let's see how much. I'm not sure if we're going to see prices here. But anyway, I remember I looked at it. It cost a good chunk of change. Anyway, so yeah, that was another deviation from what we were doing, but I think it was interesting. So for anyone interested in what John does, your ultimate goal is CCIE, Cisco Certified Technician. But your first step in that would be the CompTIA A+ and Network Plus certifications. So CompTIA offers a ton of certifications. Let's take a look at all of them. IT Fundamentals, A+, Network Plus, Security Plus, Cloud Plus, Linux Plus, Server Plus. You see how it goes. And you can obtain all these. And that would be the idea. Like, I guess this is the one that is the basic one, the IT Fundamentals. Okay, let's look at that one.
VPSs, and they talk about this game called 5M a lot.
5M, yeah, 5M. What?
Yeah, I'll talk about that a lot. I'll talk about that game a lot. And with the VPS, you could do on those things. You can host things off of it. Like you can host 5M servers off of it. All types of games and stuff like that. I used to work for a company. That company called RetroHost.com. But everything went to craps on that, and we had to, get our trademark back because someone tried to use our trademark, and it was all screw over. But I had an amazing time over there.
Cool, man. Here's something I would download. It's called VirtualBox. You download this on your Windows computer, and then you can load Linux within VirtualBox and run it from your Windows desktop. So VirtualBox, that's what I would run. And then I would go and download like a Linux distro. And you can choose from any of these: Ubuntu, Arch, Fedora. The one that everyone typically wants to download is Ubuntu. And then you can load Ubuntu directly into that virtual emulator of a computer on your Windows desktop without having to dual boot and partition your hard drive and all that stuff. So you can actually run Linux on your computer without actually having to boot directly into Linux from BIOS. And there's a ton of distributions. So anyway, I better get back to what I'm actually supposed to be doing here. It's just too much fun to start talking about IT. So, but it's good to know about Mess Work. I'll definitely go talk to her. All right. So let's actually do some problems.
Okay.
Or at least a couple. Or I'll get them pasted in. Okay. So this goes with Paul's rule: b to the x equals b to the y, then x equals y. Okay, so I'm going to go over here. This is kind of my parallel notes would be from Paul. Okay. I don't know what happened. Nick, if you have to choose a college, you might want to go to Lamar down in Beaumont, because that's where Paul teaches, and you could take his class. Tell him, hey, Morelli says hi. All right. Hello, who's here? Oh, hey, Matthew. What's going on, bro?
So Just got out of church.
Ah, welcome back. Well, that was good that you went there.
Yes, sir.
What we're doing here is just taking a look at some of these exponent rules. These logarithm rules. And we're going to take a look at these cool examples right here. And now I see the lag is kind of creeping up. So when we first started the stream tonight, the lag was almost nothing. And now it's creeping up to about 4 seconds. Anyway, basically check this out. If you have 5 raised to the power of, yeah. Okay, right. 5 raised to the power of 3x equals 5 to the 7x minus 2. Then because these bases are the same, you just write 3x equals 7x minus 2. Okay, so you solve this problem like any other algebra problem. We'll gather like terms, like subtract 7x from both sides. And here we get negative 4x equals negative 2. Divide both sides by negative 4. And we would have x equals 1/2. Let's see if that's right. Let's go back and look at the solution. Yeah, 1/2 equals x.
Mr. Roy, can you show up? Oh, never mind.
What?
I think you can show back up for a second. I lost you there for a second.
Okay, sure. I'm going to do a bunch of problems. So we basically verify this. That if we have, I'm just going to make one up. If we, Nick, you give me a number between 1 and 10.
5.
Okay. Well, not 5 because we just had one with 5. Any other number but 5.
7.
Okay. 7. And then Matthew, can you give me a number between 1 and 5?
I'll go with 2.
All right. 2. So we'll say 2x squared minus 4. Okay, and I'm going to set that equal to the same base that Nick gave me, 7. And now let's set that raised to the power of x. Okay, so the 7s, because the 7s are the same, we can bypass a lot of our logarithm rules and just set the exponents equal to each other. When the bases are the same, you can just set the exponents equal to each other. So we just drop, the 7s just go away. It's like they cancel out. Okay, so the 7s don't matter anymore. We don't care about the 7s. Now we're going to have 2x squared minus 4 equals x. Okay, so now we just get this in standard form. Okay, so we'll subtract x from both sides. Cancels out on the right. We have 2x squared minus x minus 4 equals 0. And then, like what I've told you guys to do at this point is, instead of trying to factor this by yourself, I don't even know if it's possible to factor it without doing a lot of work. Let me see. Let me think about it. So it would be 2 times -4 would be -8. So I would need two numbers that add to be -1 and multiply to be -8. I don't think I could think of them. So let's just go to Desmos and put in 2x squared minus x minus 4 and get the answer. Wait, I've got Desmos open. Okay. (2x squared minus x minus 4. 2x squared minus x minus 4. All right. So what we're going to find is the solutions. There's two of them. 1 and 2. So that would be your answers right there. Okay. So you're kind of bringing the quadratic knowledge back in. So what we would do is just kind of paste this in here. Say, well, okay. X equals -1.186 and x equals 1.686. And this would actually be the answer, okay? If you were given this problem. Let me rewrite it without all this junk. If you were given this problem and it said solve for x, and that's what your problem was, then what x is, you would say, well, okay, I did. Here's the answer right here. That wasn't too bad.
That was pretty easy.
Pretty easy. Get it in standard form, throw it into Desmos, and just get the answers. All right, so let's go back to Paul's notes, see what else Paul's got for us.
That was actually. Are we still doing the exponents or the exponential right now, right?
Yeah, we are. Yes, we are.
Okay, yeah, that was pretty dang on easy.
Mm-hmm. So now I'm just, you say that now, right. So here's the rule, all right? Let me go back and let's put in the rule that we actually just exploited. And I'm going to rewrite this in ln terms because logarithm it's not the same as the natural logarithm, but the rules are the same. So we're not going to worry about log for now. We're just going to write oops, I'm going to be black here. I'm going to do ln, okay. And then we'll have open parentheses a raised to the r, okay. That is equal to r times ln of a. Now I know when you see letters only, it makes no sense. But let's go back and do Paul's example. 5. Let's do the next example. See the example B. 4 to the t squared equals 4 to the 6 minus t. Okay.
Mom, so you're
Let's see here. 4 to the t squared equals 4 to the 6 minus t. All right, so we're going to follow the log rules exactly. All right, forget about the bases being the same. That doesn't matter. Let's just follow it. What it's saying here, guys, is that you take the exponent and you bring it down and set it in front of the logarithm, and then it goes away. Okay, so let's follow that same process here. I'm going to take t squared, put it down here, and multiply it by the log of 4. So let me show you what I mean. We'll write t squared times ln of 4, okay, equals, and now I'm going to do the same thing here. I'm going to take this dude, move him down front here, and then I'll take the ln of 4. So now I've got 6 minus t. Oh, and then this will be multiplied by the ln of 4. Okay. Now here's the beautiful thing, and this is why when the bases are the same, these problems are really easy. So right now this looks like a mess, but check this out. On both sides of the equal sign, on both sides of the equal sign, I can just divide by ln of 4 because it's the same on both sides. Now look what happens when I do that. This is something divided by itself, so those cancel out, and these cancel out. Which brings us to this position here. Now all that's left is the t squared on the left, and then the 6 minus t on the right. So we got t squared equals 6 minus t. Okay, so once again, guys, we're back here with this quadratic situation, and we're just going to get everything on the left side, set it equal to 0, write it in standard form, and plug it into Desmos. So we have to subtract 6 and add t. Okay, that's going to be one big move. And I'm going to do that to both sides. Subtract 6 and add t. These cancel out, and I've got 0, which is what I want on the left. I mean on the right. And then on the left, I've got t squared plus t minus 6 equals 0. Okay. Now this is actually, if I forget the t's, let's write it with x's. This is x squared plus x minus 6 equals 0. So this kind of looks like something we might be able to factor. I need two numbers that add to equal 1 and multiply to equal 6. Can you think of them? All right, so let me show you what I'm thinking of here. I'm thinking that C, let's do A equals B equals C equals. All right, so A equals 1, B equals 1, and C equals negative 6. Because C is negative, I know that my factors will have different signs. And because B is positive, I know the largest number will be positive. So let's take 6 and break it down. I got 1 times 6, and I got 2 times 3. So 1 and 6 are possibles, and then 2 and 3 are possibles. Okay, so we're going to give the big number a positive sign. And the small number is a negative sign. All right, so negative 1 plus 6, well, that's 5. Negative 2 plus 3, well, that's 1. Okay, so this doesn't work because it doesn't add to equal 1, but this does work. So my factors are negative 2 and positive 3. Negative 2 and positive 3. So we'll write this in factored form now. We factored it. We didn't have to use Desmos on this one because it was easy. So x minus 2 times x plus 3. Just set these factors equal to 0 and solve for x. Okay, so x equals 2. Subtract 3 from both sides. So x equals negative 3. So these are my two answers. Okay, right here. So that was that example. Let's see if we were right. 2 and negative 3. So we did... Wait, which one do we do? Wait a minute. What was I doing? Where did I get that problem from? Oh, 7 to the 2x minus 4 equals 7x. No, that's not what it was. It was 4 to the t squared. Okay. Where was that problem at? Oh, here it is. Okay. So let's see if we were right. Yep. T equals negative 3. T equals 2. So we go down here and we just change to x. So x equals 2. X equals negative 3. It's the same answer. We got it. So that is where quadratics will come back into logarithms. But that was really fun. I really enjoyed that. Okay, so now what? Okay, well, here's a situation in number C where the bases are not the same. So it's 3 to the z equals 9 to the z plus 5. Let's go back here. Okay, so 3 to the z equals 9 to the z. Was it z plus 5? Wait. Z plus 5. Okay. Z plus 5. Okay. Now, this is kind of interesting. So we could just follow this rule, and we'll do that. Okay. So we'll bring down the z. So z is going to go here, and it's going to be eliminated from the exponent position, and then we multiply that times the natural log of the base, which is 3. Okay, same thing's going to happen here. We're going to take this dude, and we're going to bring him down here, and we're going to multiply that times the natural log of 9. All right? So let's do that. The next step would be z times ln of 3, and that equals z plus 5, okay, in parentheses, times the ln of 9. Okay, now I believe that there's something cool that Paul will show you where 9 is equal to 3 squared, and that's somehow relevant because then you'd have the same base, but we'll leave it alone for now. So now we want to get, we want to multiply this ln of 9 through the parentheses. So now I've got z times ln of 3 equals z times ln of 9 plus 5 times ln of 9. Okay? And so now I can subtract z times ln of 9 from both sides. Should be putting these symbols here. Z times ln of 9. All right, and so on the left side, I'll have z times the ln of 3 minus z times the ln of 9. And that's going to equal 5 times the ln of 9. Okay? So now what we can do is factor out from both of these terms a z. All right, so now I have z, open parentheses, ln of 3 minus ln of 9 equals, that's all in parentheses, and that equals 5 times the ln of 9. And now I can get z by itself by just dividing both sides of this equation by this whole thing, ln 3 minus ln of 9. Same thing over here, ln of 3 minus ln of 9. Okay, so these cancel on the left. And now I've got z all by itself, which is what I wanted. So z equals 5 ln 9 divided by ln 3 minus ln 9. Okay. So let's put that in the calculator because that's a number. So we're going to have to go to the calculator here. And we'll clear all this out. So we're going to hit alpha y equals enter. And then we're just going to put in, we're going to put in 5 ln 9. 5. And then I'm going to hit this ln key right here. 5 ln and then hit the 9 key. Okay, that's all that's on top, right? Yep. Over ln of 3. Back to the ln key, okay? ln of 3 minus the ln of 9. So this looks just like the expression we had before. Okay, let's hit enter and see what it is. -10. How interesting. That's interesting. And now I think I see why. Now I think I see why that's so interesting. Because look, the ln, so let's just look at 9. 9 is the same thing as 3 squared. So what if I went and put this everywhere I saw a 9? So look, z equals 5 times ln of 3 squared. Okay? Check this out. It's going to be cool. You guys are going to like this. And that's ln of 3 minus ln of 3 squared. Well, remember, if I have ln of 3 squared, that's equal to 2 times the ln of 3. So let's do that everywhere we see ln of 3 squared. So now z equals 5 times 2 ln 3. Okay. All over ln 3 minus 2 times ln 3. And what I love about this is that now I can cancel out all the ln of 3's. So let's check this out. So now z is equal to just 5 times 2 over 1 minus 2. Oh, but wouldn't that, yeah. So now look at this. So 5 times 2 is 10. Over 1 minus 2 is -1. So 10 over -1 is -10. Was that the answer? Oh, yeah. That is exciting. That is super, super cool. That was like a ton of mathematics. Now, the easier way to have done that was to have recognized this. All right. So going back to the beginning of the problem, which was 3 raised to the power of, so it's 3 to the z equals 9 to the z plus 5. Let's go back here. 3 to the z equals 9 to the z plus 5. So what we would say here is we'd say, well, okay, 3 to the z is equal to 3 squared, all raised to the power of z plus 5. Okay? Very, very interesting. So here's how this is going to work. We're going to take the ln of the whole thing. All right? So that means I'm going to take the ln of 3 to the z and set that equal to, well, wait a minute. So yeah, I'll take the ln of 3 to the z equal to the ln of 3 squared to the z plus 5. Okay? I'm trying to see where that helps me do anything. I know it's going to be something interesting. I want to look at Paul's solution and see what clever thing he came up with. All right, here we go. See? This is what he did. Look, check this out. He used that. So that's what he wrote. All right. And then, he did the product rule. I mean, the power rule. Okay. So now here's what we're going to do. We are going to do the power rule. So before we do this ln business, we're going to do the power rule. Now I see what he's doing. This is really clever. 3 to the z equals 3 to the 2 times 2 plus 5. So now 3 to the z equals 3 to the 4 plus 10. Awesome. So now these bases are the same, which means we can just drop them entirely and write z equals 4 plus 10. That doesn't make any sense. That's not right. Hang on. Oh, no. You know what I did? I interpreted this as a 2. I'm a dumbo. That was 2z. See, I'm seeing that z as a 2. 2z plus 10. There. So now z equals 2z plus 10. Very clever. Subtract 2z from both sides. And now you've got z minus 2z, which would be negative z equals 10. So z equals negative 10. Wow, that was much simpler. There was no logarithms involved. This was his solution. So here's Paul, right? And then here's my solution. Look at this whole nightmare here. Then compare the two. Like, let me actually copy his. Oh no, I'm gonna get some of that other data. See if I can grab it. How did I leave this guy out? You need to go up here, bro. So this was my solution. His was easier that way. Okay, well, we've kind of run the clock out here. That was interesting. So there's a lot of fun stuff to do with logarithms, in other words. And I think it's time to sign off here because I'm getting tired. And I'll try to finish formalizing this into more of a lesson plan structure tomorrow. We'll get our feet wet with these logarithms. Thanks for watching, guys. Let me close this out. Close out Desmos. We'll check the live stream. See what our analytics were like. 31 playbacks. Yeah, it's not the most playbacks in the universe. 10 minutes of watch time. Okay. And then Discord. Awesome. I just love this, that this is there. And great. It was great. So thanks for watching. And we will, I can't wait to teach you this stuff. Okay. So good night to everybody. Good night to Jasmine, Emma, Nick, Matthew, and anybody else who hopped on the live stream tonight. Y'all have a great night. And I look forward to being your teacher tomorrow. Bye, everybody.